We're still looking at function notation, and now we're going to look at solving real-world problems. All right, example 5 says the graph of G shows how far a helicopter is from its destination after taking off. The function f of x equals 350 minus 125x represents a second flight. So that equation represents a second flight, where f of x is the number of miles the helicopter is from its destination after x hours. Which flight takes less time? All right, so the first flight is graphed right here. It goes from a distance of 300 miles in 3 hours. So it looks like it's traveling at 100 miles per hour. All right, so let's see what the second flight looks like. All right, so the first thing we would do is make a table of values. So let's quickly make a table of values. So we're going to have x and f of x. So if we have x and f of x, so we know that we can start with 0, 1, 2, 3. And why am I starting with 0? Because x is the number of hours. We can't have negative number of hours, so I'm not going to use any negative numbers this time. So hours of flight time, basically what we're doing. So we know at 0, it's going to be 350 miles would be your f of x. All right, so what happens if you plug in a 1 here? All right, so 350 minus 125 times 1. 125 times 1 is just negative 125. So 350 minus 125 is 225. And then take and plug in a 2 here, because remember, x is our independent variable, so we got to choose these, but we're looking at flight time. So again, they have to be positive. So 2 times 125 is 250. So 350 minus 250 is 100. And then if you plug a 3 in here, we're not going to be able to go quite that far. So 3 would be negative, let's see, 375, which would be negative 350 minus 375 would be negative 25. So we're not going to be able to have a negative distance so that we know that one's going to be too far. But if you wanted to graph this and kind of see what this would look like, this one starts at 350. Your initial value is 0, 350. And then 1 would be about 225, so it'd be right in here. And then 2 hours would be at 100. So it actually crosses here, becomes the same after 2 hours. And then you can see that it would have finished the number of miles before it got to 3. So probably in here somewhere. So you can see it is going to be a linear equation. All right, and it is going to be, looks like slightly less. It looks like flight 2 is going to be slightly less time than flight 1. But if you want another way to check it, besides looking at the graph, you could also plug your initial value in for your function and see what x would be. So remember, x is your number of hours. So we have f of x equals 350 minus 125x. And this was given. See, this is our function here that is given. The function represents a second flight. All right, we also know that our initial value is 0. So if we plug in 0, we can find our x value. So this is our dependent but this is our intercept. So this is our y-intercept here. We're just going to plug in a 0 to see what we can solve for. So if you subtract 350 from both sides, we're going to get negative 350 equals negative 125. Divide by negative 125 on both sides. All right, so negative 350 divided by 125 is 2.8. Remember, a negative divided by a negative is a positive. But 350 divided by 125, 2.8. That is less than 3 hours. You can see that that would be between 2 and 3. So again, this is another way to check it. And when you check it, you can see that 2.8 is less than 3. So that confirms that the second flight takes less time. So the second flight would take less time. All right, so because 2.8 is less than 3, the second flight takes less time. All right, last example, evaluating a function of two variables. Example 6 says evaluate each function at the given values of the independent variables. All right, so a function of two variables is a function where the inputs are ordered pairs. So each input, x and y, is paired with exactly one output. Okay, so what does that mean? That means a function of two variables can be written using function notation, such as f of xy, like this, or a newly defined symbol. So it could be a star, a triangle, whatever. But in both cases, the x and the y are independent variables. That means that you're going to substitute both of these into the function here to be able to solve and get the answer. So let's see what we get for A part. All right, so let's start here with A. So we're going to have A is f of x and y, and it tells us that x and y is 3, 4. All right, so if we substitute 3 and 4, and again, remember, function notation, this is basically telling us what the name of the function is, and then this tells us what to do to that function. So we're going to do 2 times x is 3, y is 4, and then minus x. So it tells us to take 2, multiply it by x and y, and then subtract x. And it gives us x and y, the variables here, and we simply substitute those in and then simplify. All right, so remember this is the name of the function, so it stays the same. We don't do anything with the left side here. Again, this is just telling us that our x is 3 and our y is 4, and that's what we're inputting to this function. All right, so on the other side, we've got 2 times 3 is 6, 6 times 4 is 24, so we've got 24 minus 3. All right, so we've got f of 3, 4, and that equals 24 minus 3 is 21. All right, so this would be our independent, and this would be our dependent. All right, so for B part, okay, so they're using the triangle here instead. So instead of using f of x, they're just going to say x triangle y equals, and then xy plus 8. So we know that x would be the first variable, so 5. So we're going to put in 5. And then we're going to multiply that by our y value. Okay, it gives us our y value here of 2. And then it says to add 8. All right, so x would be 5. Triangle y would be 2. That's the name of our function again. They're using just a symbol this time, triangle. And then 5 times 2 is 10. 10 plus 8 is 18. So 5 triangle 2 equals 18. This would be the independent variables. 18 depends on the x and y that you put in. All right, so the only thing left is your self-assessment. So you should go through here and practice a few of these and see what you come up with. If you have any questions, please let me know.